name is Pragati PH. So my project is about web-based visualizer for structural representation of C programs. The aim of this project is to help users understand how a C program is internally represented using tokens AST, CFG, DFG and CPG. So the first is introduction. In modern AI, coding assistants such as ChatGPT, GitHub, and Copilot do not read code as a plain text. They analyze program structure, execution flow, and data dependencies. This project provides a web-based tool that visualize these internal representations for C programs. So here we use it allows the user to enter a C program, generate important structural representations such as tokens, abstract syntax tree, control flow graph, and data flow graph. Problem statement. The problem is that beginners find it difficult to understand how a program is processed and internally. This project solves that by generating visual representations such as tokens, AST, CFG, DFG, and CPG from a given C program. Objectives. So it is used to develop a web-based visualization tool. It performs a lexical analysis and generate tokens. It is used to create and generate abstract syntax tree, data flow graph, then control flow graph. It is used to understand the concept of code property graph by combining different program representation, and the study of the role of automata theory and AI coding assistant in source code. Next comes the system architecture. So when the user enters a C program, the system performs a lexical analysis to generate the tokens, such as AST generation, CFG generation, and DFG. Finally, all these representations are combined in a code property graph and displayed visually. Tokenization. Tokenization means it is the first phase of the program analysis. The source code is broken into small meaningful units called tokens, such as keyword, identifiers, operators, constants, and symbols. For example, if um, a program has int a is equals to 5, so here int represents to the keyword, a is a identifier, equal is a operator, and 5 is a constant, semicolon is a symbol. So this is how the tokenization is used. The purpose of this is to help identify basic elements of the program. Next comes abstract syntax tree. Abstract syntax tree is nothing but it is a hierarchical tree that represents the syntax of the program. It shows the relationship between statements and makes program's analysis easier. Here is the example structure: function, declaration A, declaration B, if statement. So the benefits of this abstract syntax tree is to represent a program structure, so simplifies code analysis used by compilers and AI tools. Here we have the example which we have performed in our web page. Here program is a main function. In program we have include std.h and function as int main. So this is a main function. The declaration is declaration int a is minus 5, and we have used if statement. If a is greater than 0, return 0, then at last it will print it, is it a positive or negative. So this is how abstract syntax tree works. Next we have control flow graph. So Control flow graph. So it shows the order in which program statements are executed. It helps in debugging, testing, and compiler optimization. The benefits of this is help to understand execution path, useful for debugging and testing, supports compiler optimization. So here we have the flow control flow graph, the start point and declaration part, condition part. It says whether true or false, then it will gives as a output. Next we have data flow graph. Data flow graph, it is used to show how data moves between a variable and operation. It helps in identifying variable dependencies and optimize programs. So the benefits of data flow graph is it shows the variable dependencies, helps and track the data usage, support program optimization. Here we have the graph. For example, here we have taken a is equal to 5. So the main function and whatever the variables are used, it will show in the data flow graph. Next we have code property graph. Code property graph means it combines all AST, CFG and DFG into a single graph. It is widely used in security analysis, so vulnerability detection and AI based code understanding. The formula of this is code property graph is equals to AST plus CFG plus DFG. It includes all applications. We use this in security analysis, vulnerability detection, static code analysis, and AI based code understanding. This is the graph. It includes both all AST, CFG, and DFG. Then we have how automata is connected. Connection to automata theory. It says it is automata theory forms a foundation of compiler design. Finite automata, it is used for token recognition, context free grammar for praising and AST generation, state transition to control flow and analysis. So therefore this project directly applies concept and learning in automata theory. Conclusion: the project